Hello. Let's start with creating a root CA. I have created a new folder, lab02, for this purpose, and I've made different subdirectories to store the new keys. There's also an index file, and there's a serial file that starts from 1000. As you can see, it starts from 1000. Let's copy the configuration file from SSL's folder to this folder. As you can see, the OpenSSL file has been copied. Now let's try to edit the file. Let's change the path to the folder that we just created. That is lab02. All the other files have been created except the keys, which will be automatically created. Now let's create the key. The process has been started. Let's start with the passphrase. The country can be US, state Arizona, Phoenix. I'm just going to name it CSE598 since this is the course. And the unit name to be computer network security. I'm just going to type my name, my email address. As you can see, the key has been created. Now let's see, as you can see, the CART and CA key have just been created. Let's start with creating a certificate signing request. Let's create the public and private keys. Let's create the signing request. Entering the same passphrase as I did for Suzuki before. Let's enter these details like before. Locality name is Phoenix. Organization name is CSE598. Now let's skip the optional details. Now let's try to issue a certificate. We have created the certificate. Now let's sign it. Let's commit the certificate as well. As you can see, the certificate has been signed and sent. Let's display the contents of the certificate. As you can see, these are the contents of the newly created certificate. Let's combine the key and the certificate in one file. Now this is done. Let's copy the certificate. Now once we've done this, let's start the service. As follows. Now the service has been started. Let's try to access the website on Mozilla. What we have here is that the connection is untrusted. As you can see, after the certificate has been added to Mozilla, we can access the website. Now let's try to access the same website using different domain addresses. Let's try localhost. As you can see, it's untrusted. Let's try the actual loopback address. We get the same untrusted website. Let's finally try the IP address of the machine. We get the same result. This is because the certificate only has one name and there is no conversion between the domain name and its IP address. Now let's change one byte in the server.pem file using kicks. Let's change this to say 8. And start the server again. As you can see, as the single byte has been modified, OpenSSL cannot decrypt the file. Now let's change it back. to what it was before. And let's run it. As you can see, the server runs fine now. And we can access the website. The scp command has been used to transfer the ca.crd file to the Kali VM. As you can see, the website cannot be accessed as of now because we have not selected the certificate. Let's try to add the certificate. This is the certificate that we want to use. Select OK. Let's try to access it again. As you can see, we can access the website from Kali VM. In the same fashion as we did on the Ubuntu system, we can try localhost or the IP address of VM1. This does not work as expected because the IP address is not converted to the domain name, and the certificate is only valid for that domain name. Now let's analyze the speed of RSA and AES. This is creating a private key for RSA algorithm. It's taken 4.92 seconds to do it. Creating a public key of length 512 bits, and that's taken 4.93 seconds. As you can see, RSA's key generation stays around 4.92, 4.93 seconds, irrespective of the length of the key. Now let's analyze the speed of AES. As you can see, the AES processing speed hovers around the mark of 1.5 seconds on an average, and it remains the same for a 192-bit key as well. The processing time is pretty quick compared to that of RSA.